And welcome everyone. I'm very excited today to share some of the learnings that we had when we tried using ChatGPT to improve a computer vision model. If you have any questions during the talk, just drop them into the chat. I'll try to be looking at the chat. Otherwise, we'll have a Q&A at the end to go over anything that's remaining, but happy to just see the questions as they're flowing in through the presentation. So first, a quick intro on myself and Encord. So I'm Eric. I'm the co-founder and CEO of Encord. I've historically been focused on the research and development side of the business and am very focused on a lot of our active learning toolkit at the moment. So Encord, we are an active learning platform for computer vision. So we help companies and institutions and groups that are building AI models evaluate their training data sets, manage them, annotate them, and build active learning pipelines so they can get these models working properly in production. So we work with some of the leading players in computer vision across multiple verticals: healthcare, retail, autonomous vehicles, agriculture, etc. And so are in a very privileged position because we get to see a lot of the cool things that are happening in AI at the moment. And we have a team from some of the best companies and universities. So one of the reasons that we're extremely excited about where AI is now, because it's almost like the future is already here. And you can see the graph on the left where there's this exponential rise in papers that are being devoted into machine learning and artificial intelligence. We're about 10 years into the deep learning revolution, and we've already seen a massive proliferation of use cases and applications. So right now, AI feels like the place where a lot of very talented minds are putting their mind share, and you can just see the progress and the pace by which it's moving. Historically, there's different fields that have different places where a lot of smart people would be, be working and be applying a lot of their thought to. Maybe like 50, 60 years ago would have been physics, and then 20, 30 years ago is finance. And it really feels like AI is in that spot now. And with a lot of smart people working on things, you get a lot of cool applications that are built out of it. So you see autonomous vehicles are still on the horizon, but you have many interesting use cases: autonomous navigation systems and self-diagnosing systems, and automated tomato pickers. And we've seen many really interesting, sometimes quite exotic use cases. The one that I usually like to quote is a company that is quite successful that does facial recognition for cows. So they just have a system that only recognizes cow faces. But we're in a very auspicious timing for this talk because GPT-4 just came out. And as you can see, it seems to improve quite drastically over GPT-3 and the previous versions. GPT-3 was already very impressive for what it could do. It really captured the public's imagination. ChatGPT was the fastest growing application in history. So it got up to 100 million users within a month or so, maybe a couple months. So the public is really engaged now with AI, and GPT-4 seems like a quite dramatic step change up from GPT-3. So we're still very much in the early days of where AI can take us. So it's very exciting to be a part of it. And one of the main questions is, what's going to drive the next layer of development, the next set of improvements that we will see in AI systems? And that comes down to this very hard question of, can AI be used to improve AI? Because once you get into a situation where you have this self-reinforcement cycle, where you have an AI system that's developed and can kind of improve itself, then you can get this positive reinforcement loop where these systems get very good very quick. And that brings down to these philosophical questions about the singularity and things like that, which I think we're still quite a ways away from. It is not really the main point of this talk, but whether AI systems can improve other practical AI systems, ones that we're using in normal day applications. So this is a very broad, big question. Can AI improve AI? And it's very hard to solve. But usually with hard, big questions, you want to break it down into smaller subcases, and you want to build intuition by smaller, easier questions. So our smaller, easier question that we're going to address today is, can ChatGPT be used as a ML engineer? Specifically a computer vision engineer. So using ChatGPT for a domain and modality by which it wasn't trained, and see if it can actually effectively do a good job in improving a computer vision model. So this is a question that we were quite curious about. Encord is a computer vision focused company. So while we're following the development in large language models and ChatGPT, our expertise is in computer vision. So a natural curiosity that we had was, well, can we take these large language models, ChatGPT in particular, and really apply them into computer vision, see what the results would be. Okay, so this is what we're going to get into over the talk, and how we did this and what we learned. The first thing when you're asking a question like that is you want to narrow the scope even smaller to, can it be used as a functional ML engineer on some concrete problem? So we decided the problem that we wanted to solve was, can ChatGPT improve an object detection model over pandas? And we use pandas because, one, in honor of the Python library, which I know and love and have used quite a bit, but also because they are very cute, as you can see from some of these pictures. And when you're going to be doing an experiment with some kind of a computer vision use case, you might as well choose something that is cute rather than a set of painful domains, which we have done quite a bit. At Encord, we work a lot within healthcare, and I have seen more than my fair share of colonoscopy videos where, I mean, it's for a great use case, trying to detect cancer within a colonoscopy, but it's not very pleasant visual media to have to explore and go through large quantities of. So the problem is we have a model that we want to detect, do accurate detection of pandas. Can we do this effectively? And can we use ChatGPT to help us? So you notice from the pictures on the right here that we have pictures of actual pandas, but we also have pictures of monkeys and a guy dressed in a panda suit. We intentionally curated some data that would be noisy or be mislabeled. We did this from the YouTube VOS dataset. It's a known open source dataset. We relabeled it ourselves. It's a very interesting data set that we've spent some time on, more than in just this panda use case, but which we wanted to use as the main source of truth for this project. And we wanted to check whether ChatGPT could really overcome the issues and problems within the data set. So the monkeys are labeled as pandas, and you have some other bad panda annotations and misplaced bounding boxes and things that were littered throughout the data set. Okay, so that's the scope of the problem, really improving a panda detection model over some noisy data. This is realistic. It's something that we see in the real world all the time. So now the question is, how are we going to do this? So we elected to take what is considered a data-centric approach to this problem. And now there's these two paradigms within artificial intelligence developments. There's the model-centric approaches and then the data-centric approaches. And model-centric approaches are the more traditional paradigms where what people tend to do is they take kind of traditional architectures and parameters, and they really fine-tune and optimize over the model itself to try to improve the performance of an application. So they have some big chunk of code which instantiates the model with a lot of parameterizations and weights within the models and hyperparameters that govern the training and inference of the model. And they're really they're using that, tuning that black box to try to get the model to work well. But there's another approach which we find actually is practically much more effective in the real world, and that's this data-centric approach. So instead of focusing your time and attention on the model and improving the model, you should actually think about the data, and specifically the training data that's being used to train the model in the first place. Because the model will always be rate limited by how good the data is. And it tends to be a lot, you get a lot more leverage, a lot more bang for your buck by improving the data relative to improving the model. The reason why the model-centric approach has been the main one that people have taken and think about is because in academia, what they have is these large benchmark data sets, which are fixed, ImageNet, for instance, and then people just focus on trying to make the models as performant as possible on this static benchmark data set. But in the real world, in industrial AI use cases, the data is actually quite in flux, and the data is like a huge degree of freedom that you have to improve the application. And the data selection, the data cleaning, the data annotation, these are all very, very important ingredients to making sure that the end application is performant. So for this problem, we decided to forget all the model stuff, just focus purely on the data, try to get ChatGPT to take a purely data-centric approach. There's one more practical reason why we did this, because the model-centric approach is often just iterating over, trying many iterations of a model and parameters and just running optimizations. And that was less interesting to us than the conceptual problem solving that you get with data-centric approaches to AI development and improvement. All right, so data-centric approach. Now, what are we going to use to instantiate that data-centric approach? Well, there's two things here. One is we're going to use ChatGPT. So we're going to use ChatGPT as our sole idea engine, our sole ML engineer for this problem. And then we're going to use our internal data-centric tool called Encore Active. It's an open source tool to really improve the data and to like instantiate ChatGPT's ideas that it comes up with as it's going through the problem. So to get into what that looks like, we'll also contrast how people are taking these data-centric approaches now compared to the main ways that they could be. And a lot of it being done now is de facto by just visual inspection. So people just go through and look at individual images for things and try to find errors, and they'll come up with their own ad hoc heuristics and methods and scripts to find different ways to curate the data, or to find labeling errors, or to optimize the data selection and sampling. And it's not very systematic. Versus the way that Encore Active does it is they do it with this method called quality metrics. So these quality metrics are parameterizations over the data labels and model predictions. So there are particular ways of subsetting the data and labels and the model results in ways that are conceptually palatable for humans to understand. And we'll get into what this means in a second. But this tends to be quite useful because you can really start looking at slices of your data in ways that are categorically interesting and maybe semantically relevant for the particular problem that you are working on. So the problem with doing this kind of ad hoc individual investigation is that it doesn't scale for large data sets. We see it's often done for side projects and student projects, but it's not something which will work for a real practical use case. So instead, we're going to take this quality metric approach, which is for more kind of production scale AI applications. And we're going to expose ChatGPT to this quality metric approach. And the main tool that ChatGPT will have for this, this problem is to develop and reason about what quality metrics actually matter for this problem. So to go into some examples of what a quality metric are, as I said, they're parameterizations or indexes really over the data, labels, and model predictions. And they can be quite general or quite arbitrarily specific. So some example ones that we've seen in a lot of use cases are things like the brightness of an image. So parameterizing how bright an image is within your data set can be quite useful, or looking at the the closeness of an image to its nearest neighbors within that data set is another parameterization which would be quite useful to manipulate, to navigate, and visualize. Some of them can be over the label specific qualities. So if you have bounding boxes, an example quality metric is the aspect ratio. So the ratio of how skinny to how wide, how tall to how wide a bounding box is, which again can be quite useful for particular applications. So what Encore Active has natively is it has a collection, a library of these quality metrics which you can draw upon. But what's interesting is actually writing new quality metrics and ones which are specific to a problem that you're working on. So to give an example here of the aspect ratio quality metric in the tool, we can see navigating through the object aspect ratio of the bounding boxes. So as the data is ordered as per this aspect ratio quality metric, so the ones at the left-hand side of the distribution will be skinny bounding boxes, and as you traverse the distribution, they'll get wider. So you can see this is what it looks like from a visual perspective for a person, but of course, ChatGPT won't have access to this, this visual perspective. It will be doing all this stuff through code. All right. One other component on the quality metric side is that what the tool naturally does is that it breaks down the model performance as a function of the quality metrics. So you can see how well the model does for the different quality metrics that are run over a specific project. This is what it looks like in code form. So if implementing a new quality metric, and this is the main portal that we will have for ChatGPT. So ChatGPT will essentially be creating its own quality metrics and ideas of how to use quality metrics to improve the object detection problem here. What you're seeing now is the main tool that we'll have in the problem that we tried. All right, so that's all the setup, the problem, the tools that we use. Now let's go through how we're actually going to do this. And I think this is where it gets a little bit more interesting. So with any data science problem, the first thing that you want to do is you want to establish some initial benchmarks. So what we did is we said, well, how well can we just create a random Panda object detector model from randomly sampled data that we have, noisy or unnoisy. Then the second thing is specifying the problem that we have to ChatGPT and asking it for ideas to improve the data cleaning, the label selection process, the ability to find label errors, again, through this strategy of quality metrics. Then we don't want to write these quality metrics ourselves because ChatGPT is the ML engineer here. So can we have it actually write the code to generate these quality metrics for this problem? And then we'll use the ideas that it came up with and the code that it came up with to curate new data sets and new labels for training a model on better data. And then we'll go and just evaluate how well the model did compared to our benchmark. So on the bottom here is the chart, again, re-emphasizing this data-centric approach, where what we're going to keep fixed here is we're going to keep the same exact model, same exact hyperparameters, same number of epochs, same batch size. All these things are going to be fixed for all the experiments that we're going to do. But what we're going to change is we're going to change the data that's being fed into the model and the labels that are going to be fed in the model, and we're going to change those by the quality metric approach driven by ChatGPT. So the first approach to the model doesn't do a terrible job. Actually, we just took a completely random sample of 25% of the data and trained the initial model, and then tested it on a pristine outsample data set, which was always isolated from the training data set. It came from a different set of images from the YouTube VOS data set, and actually had 100% ground truth labels on. So we're always testing against the cleanest validation data. All right, so now the question is, can ChatGPT come up with good strategies for finding label errors in the first place? So I just asked it, hey ChatGPT, what can we do to find label errors? I explained it, the metric approach, how we think about metrics in similar terms as what we've done earlier in the presentation. And with that context, tried to ask it what it could, different ways which it could apply these metrics and strategies to improve the data and label sets. And the main ideas that it came up with were all quite reasonable. Data stratification, so using quality metrics to figure out different subsets of data and using them to stratify the data. Then error removal, so coming up with quality metrics which correlate to potential errors in the labels, and just relabeling explicitly. So for this particular problem, we didn't want to have any manual intervention, so we didn't want to send anything back for relabeling. And the main strategy that we decided to go with, again, from ChatGPT's guidance, was this error removal idea. So using the quality metrics to find bad labels, and then curating the data based off those and trying to remove the errors. All right, so now we want to come up with ways of finding bad labels or labels which are going to confuse the model. Can it come up with specific quality metrics to this problem? So again, ask ChatGPT, do you have any Panda specific metrics you can come up with? And it came up with a lot of pretty interesting ideas. So a few of them here are the object proximity. So parameterizing the data based off of the average distance of bounding boxes within the frame. So you take the center of each bounding box, and there's a distance metric that you tag a particular image with, and you can sort all the images by this distance metric. The reason why this could be interesting is because if this distance metric is small, then probably what you have is bounding boxes overlapping each other, in which case the model will probably not do a very good job. So it's quite an interesting and relevant idea for a metric. Then the object confidence score, this is something that you see very frequently in ML engineering, is just using a model, maybe like a suboptimal model, and using the confidence scores of that model to parameterize all of the data or any new data to see how likely that model is to get that data correct according to the model's own internal calibration. Another simple one is the object count, which is the number of objects in the frame. And the last one I think is the most kind of creative and interesting one, which we'll get into a little bit later, is the bounding box tightness metric. So I'll explain that in a bit. So from an ideation perspective, ChatGPT was pretty good at coming up with what I think are very plausible quality metric hypotheses of things that can improve the data and labels. So the next question, can I actually write these? All right, it's come up with ideas, come up with ways that it can apply these. Can it write the code to do it? So I was very encouraging to ChatGPT over. It was a long conversation, so we became buddies. I said, "Oh, I like your object proximity idea. can you actually write it in practice? And here there were some issues that we had. It would write some code, but we would run it and there'd be bugs, and we would go back with bugs, and then it would say, "Ooh, an error occurred. Try refreshing your browser." You'd refresh the browser, and it wasn't very consistent or reliable with respect to both the availability, which of course that's not a too interesting a problem. OpenAI is getting an influx of requests for ChatGPT usage, but also in terms of the quality of the code that was being written. So, ChatGPT in this case, it is an ML engineer, but it's an ML engineer that is really isolated from the rest of the team, that has only access to a Slack channel, and is very, very inconsistent and unreliable. He'll just go on vacation and not go and finish the job, and will write a little bit of shoddy code. So for the actual instantiation of the metrics, what ended up happening for us was we had to go in and debug a lot of the code and make sure that it got running properly. So the ideation, pretty good. The coming up with the metrics, pretty good. Writing the metrics, still some left to be desired for this experiment. All right, now the bounding box tightness, going into this particular metric, because I think it's just personally quite interesting. One thing that we prompted it in our conversations was using classical computer vision techniques to try to find potential errors in the labels. And what I knew from the way that we were labeling the data set and all the errors that were being introduced was there's a lot of examples where a bounding box was not tight around an object, but was very loose. So you'd have a panda in the center here and like a very big bounding box around it, which when you're training a computer vision model in a lot of contexts, you don't want this extraneous background information to be used in the training of the bounding box. It can cause false correlations between what the model is trying to detect and what the model thinks it should be detecting. So you want to try to find ways in which you can find these bad bounding boxes and find better tight ones. So one really interesting idea, which kind of came through some iteration with ChatGPT, was using classical computer vision method to detect internal contours within the bounding box. So just classical contour detection that you would have seen 30 years ago in a computer vision textbook. And then looking at the main contours and looking at the aspect ratio of that main contour compared to the aspect ratio of the bounding box. And when there's a deviation here, it's likely that the bounding box is not tight around the object. Because imagine, you have a big, wide, square bounding box, but you're detecting a panda or a person which is upright, and the contours will draw this upright, type of template around the object, but the bounding box will not have the aspect ratio which matches that, which probably means that the sides of the bounding box are extraneous information. This is the quality metric that we ended up finding was the most relevant for improving the quality of the labels. And it's an idea which we now incorporated on Encore Active, is now kind of available for everyone, and it kind of came through the experimentation that we had in this process. So using all of these metrics and the debugged code, we went and we curated the data. So basically just taking the metrics which again correlate with label quality, and taking the top 25% of that, rather than a random sample of 25% of the data, and we retrained the model using that. The main factor here was this bounding box tightness quality metric. And then with this, we found a pretty substantial improvement in the the quality of the outsample validation set of the model. So you can see on the left here, the model improved in precision, but also quite a bit in recall against the random sample of 25% of the data. So it was it's quite interesting because it's hard. It's very hard. I don't know how many people have built computer vision models, but it's very hard to get improvements of this level when you're working in practice. So those were the results. And what did we learn from all this? Well, okay, can ChatGPT be used to improve an AI system? The answer is yes, for sure. We found that it improved in this particular model. It gave us ideas which are quite interesting, which we can repurpose and reuse for other use cases. Can it be used with minimal human guidance? No. So one of the hidden factors in all of this throughout the experimentation is that there was quite a lot of back and forth with ChatGPT, a lot of implicit human guidance, even in the types of questions that were asked of it. Because even this bounding box tightness metric, it came from this kind of iterated answers, and you could see that it was kind of cajoled eventually into this particular implementation, even though it came from its own ideas. It was not out of thin air. It came with a lot of kind of implicit human input. So for this version of ChatGPT, at least it's ChatGPT 3.5, not GPT-4, we found that there was a lot of human overhead here. And then furthermore, in actually writing the code and in writing bug-free code, that required a lot of human input as well, because the code templates and things that it would write, it just would not work out of the box. So what is the future of this AI-assisted AI development? I think it's going to be very similar to AI-assisted creative work and AI-assisted high-level cognitive work, where what's going to happen is a lot of the grunt work that's going to be that's normally done by people now will be taken care of by these AI tools, and a lot of the kind of base level generation of ideas. But humans will still operate in this editorial capacity. So curating the work that's being done by ChatGPT and these other models and large language models that will come after. And we found that this was very much the case for this application, where it came up with a lot of ideas, it came up with some code, and really the human came at the last moment to kind of mold these things into a practical application and stuff that would work in the real world. We'll see how the next batch of large language models come in, ChatGPT, GPT-4 included. We will refresh this experiment with GPT-4 to see if the added context that it has now, and also the multimodality, so it has some sense of what vision is, will substantially improve the results. So keep posted on what we find there. But until then, humans are not going to go anywhere. ML engineers are not going to go anywhere, but they have a very strong tool that they can use now to speed up the development of these projects and solve a lot of smaller problems. So this was the main thing that we wanted to go over. Happy to go through any questions that came up at any point in the presentation, or any other curiosities that might be out there.